Hello friends, today we are going to study automation training. What is PLC? PLC programming, HMI programming, communication and practice. These are the topics we are going to conduct it in these slides. Now what is PLC? PLC means programmable logic controllers, also referred to as a programmable controller, is a specialized computer and it is used for a commercial and industrial applications. It has no display, no keyboard, no hard drive, no printer. Now CPU and IO modules. Actually, the programmable logic controllers have a CPU modules and input-output devices referred to as IOs. As shown in picture, the module shows as a PLC and it has a IO devices with inbuilt, and sometimes the IO part is different in a different module forms, and it is a part of the CPU and sometimes it is in a other modules. Now mounting. CPU communicate with the IOs, so in most of the systems they share a backplane that physically hold them in a place and electronically connect them. Remote IO. IOS module can be miles away from the CPU and connected with the data cables, and so PLC is not limited to single cabinet or even a same building. PLC is a computer. There is no need to limit it to only digital input output. Over years, the manufacturers added analog and other numerical inputs and outputs. Now these are the instructions. To make these numerical devices useful, they included calculation capability in the program as well, so that we can now calculate for the instance. Here different kinds of instructions are showing: addition, division, sequential process, statistical process control, and PID controllers directly it into the program. Now for the communication with the PLC, the PGPC interface or PGPC setup is established. Since this is called as a programmable logic controllers, we need to program it. Most PLCs are programmed using an application running on a standard desktop or laptop PC. They communicate with the PLC using the Ethernet or a proprietary communication bus. Here the communication protocol is maybe PPI cable and MPI cable. Now standard PLC cycles: copy data from the input modules into the input image area of the CPU modules RAM memory, run the user program which modifies data in area of RAM memory including the output image area, copy data from the output image memory area to the output modules. Now it is a whole, it is see the whole scan cycle. Now memory, what type of memory, how many what type of memories are using this PLC? Central computer memory, ROM and RAM. ROM means PLC operating system, driver program and application program. RAM memory, user written program, working data. Retentive memory option, RAM protected by a long life battery or a capacitor backup. Removable memory module, EEPROM and flash memory. Now today we are going to learn how addressing the PLC. A PLC program instructions must include the address of the input image bit for the sensor or the output image bit for the actuators. The IO image addresses reflects the actual location of the sensor and actuators. Siemens S7 digital IO addressing is I4.5, supposed to be I4.5, input image I, byte 4 and bit number 5. Now analog IO model continue. Standard signal ranges. These are the ranges 4 to 20, it may be 4 to 20, 0 to 20 milliamps, 0 to 5 volt, 0 to 10 volt, minus 5 to plus 5 volt and minus 10 to plus 10 volt. These ranges can be set using the DIP switches on the analog IO models. Now SCADA. What is SCADA? A SCADA system is a collection of both software and hardware components that allows supervision and control of plants both local and remotely. The SCADA also examines, collects and processes data in real time. SCADA, supervisor control and data acquisition. Also within the SCADA software is the ability to log data for the historical purposes. Now the structural design of the standard SCADA systems starts with the remote terminal unit or RTU and or programmable logical controller or PLCs. The communication data is routed from the PLC to SCADA. Now the image shows typical architecture of the PLC and SCADA. Here remote terminal unit and two standalone systems of with connected with the HMI, and SCADA is centrally connected with the whole systems. Now this is a wireless SCADA systems in which the master computer is connected with the slaves, means other two standalone systems with the help of the wireless, and communication between master PLC and SCADA with the help of the Ethernet. Thank you very much.